Hello, Professor. My name is Mansoor Farouk. This is my presentation on Hadoop for Computer Science 591, Frostburg University. I will be talking about my paper, which stems into my slides. In my paper, we can talk about my results, the implementation, and the installation of Hadoop. I used Linux Ubuntu to do my setup. And I guess we can start with that after the introduction, of course. So what is Apache Hadoop? It's an open source software that was created because of the need for managing big data. Traditional softwares weren't able to handle such vast amounts of data, and this is where you run into the problem where how do you store, how do you process, access, govern all the structured and unstructured data. So one really good thing about Hadoop, it's scalable, which is a big plus with companies. Also, it's low cost. So Google came out with a technical paper that described MapReduce framework, which is a new way of processing data. And Hadoop had initial use and is growing to date. System design, we'll go into that. There's a lot of modules that go into Hadoop. Hadoop Common, which contains the libraries and utilities. HDFS, which is Hadoop Distributed File System, which stores data on commonly of machines. It takes care of the storage part of the Hadoop application. It creates multiple replicas of data blocks and distributes it to its nodes, clusters for computation. It is highly flaw tolerant and can be deployed on low-cost hardware. Other modules that I'll just mention, which I'm sure you know, is Hadoop Yarn, Hadoop MapReduce, Zookeeper, Hive, Pig, Uzi, HBase. And you will find in my report that it contains all the descriptions and what it is. All the modules that I mentioned, this is a very popular Hadoop diagram that you'll find online that I've included in my report, and it describes the architecture. So let's go into the implementation. The implementation I have again laid out in list form for you. Again, I'm doing this in Ubuntu on my virtual machine, and the commands to actually install Ubuntu, install Java, add Hadoop, add a user, login, create new key, SSH to the local host, download Hadoop, extract, rename. All these detailed steps are in here, and what to change and what needs to be done, permissions, paths, verifying paths, copy files, open files. Again, these are all the commands you'll find. I made a little nice tutorial while I was doing this. As you can see now, first step, add Hadoop user group to the system, add user to group, log in, create a new key, download Hadoop, SSH. I did a little renaming, modifying files, access right permissions, a lot of details that need to be implemented within the directory. Navigation. Again, this is a tutorial to show you how I did step-by-step of installing and implementing Hadoop on my Linux machine, as you can see. And these steps are, again, not with the screenshots, but in my report you'll see each step detailed for you. Let's go talk about the code. The code used for processing the data. Now you'll talk about which data, which I'm sure you know. So the instructions for Hadoop project: install the data set, convert it into the Hadoop file system, write Hadoop program I did in Java, and create some scenarios. So I'll talk about my code, I'll talk about my scenarios, I'll talk about the analysis data, which I will also be submitting to you, and then the charts as well. So going to the data, the code. The code used for processing the data provided includes various mappers and reducers. There are 6 jobs classes that have been written for performing various MapReduce operations. The classes and the operations which the performer described below. A record class is used for managing each field provided in the CSV file. The record contains all the fields that are associated with each and every column of the file. This class implements a writable interface in order to write and read from the file. It also creates the object of record every time whenever it is read from the file. A record is read from the file and the split operations performed on the comma separator, and the values generated are stored in the corresponding record fields. Along with this, null check is also performed, and I'll be submitting my record.java file for you to view. This class groups the data by actions taken in the data field. The mapper class uses action taken mapper. It reads and records from the file, ignoring the headings, and maps to the record object. It collects all the action taken fields and writes to the temporary storage. The reducer class for this is action taken reducer. This class simply counts the action taken and writes the results to output field output file path 1 while executing. So we have an age group mapper, age group reducer, expiration date mapper, expiration date reducer, status mapper, status reducer, year-wise first mapper, year-wise first issue reducer, and credential type mapper, credential type reducer, constants, which is a class for providing all the constants, and the starter, which is the execution. So based off your guideline, then we go into user manual of how to load the data, run the data, and I provided in my report screenshots of me doing such that for each class, displaying the data, the results. As you can see now are the results, raw results taken. So the implementation of MapReduce code simplifies the data processing task. A large set of data was processed in a few minutes using parallel computing environment and system. The job to produce individual results without being dependent on each other. This simplified the data processing. The results are gathered in a few minutes instead of a few hours. The results obtained using are shown below. Results for action taken. Yes, no, pending. Results for age grouping. Results for expiration date. Status. Results for first year of issue. Results based on the type of registered person or certification here. And using Excel, I was able to create the charts for each one, monthly expiration date, action taken, and try to display it in the best proper format given the data that I was looking at. And again, I will be providing this to you. If you were to open the code, or actually, just so I have in the text files the raw results for each class. As well. So going back to PowerPoint. So I wrote the code in Java using Eclipse. I explained the brief, I've explained the results. It was a fairly, it was a large amount of work, but it was a fairly simple, straightforward task. So the discussion. So Hadoop obviously simplifies the big data processing or the big data problem. So huge amounts of data can be processed easily using cluster. A cluster may involve 2 or more nodes, which distributes data, and upon which the data can be easily processed. The following assumptions were made while doing this analysis. Single node for data processing. There was no fault that Hadoop bubble while processing data. the data is available for each and every field, and the system is fault tolerant, which I mentioned before. Hadoop is very fault tolerant. So talked about the results, I talked about analysis. And I will just go back and go over my report. These are my references, which I did in IEEE format as requested. I have the raw results, I have the results in charts, I have screenshots for you as well. I have detailed stuff for all the installation. And again, if you go to my table of contents, it's basically your project breakdown. From introduction, system design, implementation, user manual, results. I had a good time learning Hadoop and implementing this. I had quite a bit of experience using this before as well. Thank you for viewing my presentation.